So anyway, risk measures, we are going to go to VaR. So VaR, so basically the measure of VaR is about how so it's about being reasonably sure that you cannot exceed a certain loss at any given time, right? So is the amount of loss you are sure you cannot exceed for the next period, right? So of course, this reasonably sure, to say that you are reasonably sure, so you can say maybe at 90% or 95% confident, or even 99% confident. So we are actually going to measure this period, or the amount of surety. I can say surety in terms of percentage, right? So this is how you write your answer. I hope that makes sense. I pray that makes sense. So for a continuous distribution, this is how you are going to write your answer. So VaR, if I have to write it down, I will say that VaR going to be the value of negative t, such that t, where x is going to be less than t, right? Equals to so this is VaR, right? So this is the amount you are reasonably sure you cannot exceed, right? So we are again in this course, normally they ask a question on normal distributions. So if this area down here, it's 5%, and you are trying to find 95% VaR, so the value, this value over here, is what you are going to call VaR. This value of t is what you are going to call your VaR, or your value at risk. You can, and then we can see the same thing about discrete. For a discrete as well, your answer, so VaR again is going to be a negative value. I'm going to say VaR going to be negative t, where, right, where t is going to be the maximum value. It's going to be the maximum value of x. I have to put the small x of x, such that the probability of the returns is going to be less than that x, less or equals to p, or alpha in this case. So this is the definition of VaR for a discrete return. So in order to understand this fully, we will have to do a couple of examples, right? So this one, I think this question, so this question is from 2014 paper. It's not recent, but then the questions on VaR, they don't change that much. The answer is mostly in this nature. So the most important thing they can ask you for VaR is to find this field, is to, so they can ask you to show that VaR can be expressed in that manner. So you can see this thing carries like 3 marks. So how do you find this value? Now you know that VaR, so they asked you to define VaR of x being your return, where x is a normal distribution with mu sigma squared. Rate of return, right? Rate of return. So to find this value of VaR, it's going to be negative t. So it's continuous, right? So you will have the probability that x is going to be less than the value of t equals to this. So you can, so to find this value of t, you say that going to be equal to the probability of x, which is the return, being less than t. You standardize x. You standardize x. You will have the probability of z less than t minus mu over sigma squared, right? Actually, again is sigma, not sigma squared. We know that again that z again, so again we know that the probability of z is going to be less than the inverse of the standard normal function of lambda. So this is what we mean. So this is by definition. This is by definition, and therefore t minus mu over sigma should actually be equals to the inverse of the standard function, and then you find t. You make t the subject of the formula, and then you're going to have t going to be equals to mu plus sigma inverse of the standard normal function. So this should be your answer, right? So you take it back to VaR. So remember that VaR, they want your t as negative, right? It's going to be negative t. That's going to be negative mu plus sigma, the inverse. Any questions? So basically this thing is simplified, right? So any other question can be, again, so when you want to answer any other question, you can basically substitute the values of mu, sigma, and then you're gonna find your z-score value. So this is why they ask you to get, normally when they ask you to find this value is because the next question, you will just have to substitute. There is no need for you to go back to step number one to do it step by step. So you can basically substitute your values and then find your answer. Does everyone understand, or do I have to repeat somewhere? If you want me to repeat, you can raise your hand. Or you can say repeat, just type repeat, or you can unmute your mic and then say repeat. So anyway, I hope that we all understand. There's no one who wants me to repeat. So the next question, actually we have two questions in the same place, right? Let me see how many questions I have down there. None. Okay, so we have two questions which comes together. So we have x and y being independent rate of return. So x, they tell us that the returns of x is normally distributed. No? So they want you to calculate 5% VaR. So I am going to skip this question because calculate the expectation of E, so it's fine. We have to find 5% VaR. So we already know that to find VaR for a normal distribution, right? For a normal distribution, VaR for a normal distribution gonna be negative mu plus negative sigma, right? So you just have to substitute these values over here. So you already know that mu is gonna be 6%. It's already here. We already know that the variance is gonna be over here, and then you will have to find the z-score of 5%, right? So can you simply go to your table? I think it has to be negative 1,645. but I'm not sure. I'll have to check. Please confirm if the set score is going to be negative 1,65. Okay, anyway, this value over here. It's going to be negative 1,645. So thank you. So anyway, your VaR is going to be negative 8% plus can I say negative 1,645 sigma. The sigma was it what was at 6%. Then you'll find your answer, right? So this answer would not necessarily be your VaR. So you will have to multiply it by this value, by the million. So if they give you the million, which is h, I think they normally use h to describe this value or this present value, because x is the rate of returns, right? So you are going to multiply this value. You will say negative 6% minus 1,645. 6%. And then you're gonna multiply your answer. By million. So how do you conclude this? You say that you are 95% confident that we will not lose more than 18,700 rand in the next year. Because I think the returns are annual returns. So this one is for continuous, right? So there's another question for y, which is discrete. I am gonna do it now. I have to cycle these things together. I need to. So anyway, for y, we know that the returns can be negative 15, 1, 10, and 20, right? And they have those again, and then they have those probabilities. So we will have to find the expectation and the standard deviation before we can find. Actually, there won't be any need to find these things, because when you write your answer for VaR, we're saying that VaR is going to be that negative t, where t is going to be the maximum value of x, given that the probability of x is going to be less than x less or equals to, in this case, is going to be 0,05, 0,05, right? Because that's what our confidence interval is, right? Why did they call 5% confident interval? But anyway, it's fine. So this is the definition of VaR, right? For discrete, right? So what you can do now, you can see that you are trying to find the maximum value of t of x such that they fall under 5%, such that value fall under 5%. My advice is to visualize this answer, right? You can write, so you have your returns, you have your returns, you have your probabilities, right? So what I advise you to do is to find the CDF as well, the CDF. If you, again, so this thing, again, once you are comfortable with using VaR for discrete, then you may not have to draw this table, but then I advise you that if you don't understand very well so far, my advice is that you should always write your CDF. It will make your answer simple. So the return is going to be 15%, negative 15%, 1%, 10%, and 20%. The probability 0.04, 0.0, 0.2, 0.6, 0.16. So 0.04, 0.24, 0.8, 4, 1. And then you look at the returns that have probability of 5% or less, right? In terms of CDF, right? It's only this one. Only this one, right? And the maximum value of this number, so there is only one value, right? So it seems simply mean that our t is going to be negative 15%, right? And therefore our VaR is going to be 5%. It's going to be 15% because negative 15 times positive 15. Why would we possibly get? Will we possibly get part marks for drawing CDF? I am not sure if they will give you marks for drawing the CDF, but then this is for your own sake. If you're not comfortable with finding VaR for this is again for discrete, then I advise that you always write your CDF because it will make finding your answer simpler. Not 1, not 1, not 9. I don't understand the call. You say 1, not 9, why? Oh, 1. I'm sorry. Yes, it's 1. So I'm not sure if this is clear because I can try to draft another question. Learn a little bit about discrete. If that's fine with everyone. Do you all again? Do you all understand, or should I find one last question? I mean, like, should I do a question where we can learn more with VaR for discrete? But then I think it's simpler, I guess. If you want me to repeat, you can raise your hand, or I'm going to move to conditional VaR. How you get the negative 1,5 or the negative 15? He's negative 15. Because you are finding, so your t is going to be the value of x, right? So your x values right here in the formula, right? So you have x's, right? And these x values are going to be negative 15%, 1%, 10%, and 25%, right? This is your value of X, such that the probability is going to be less or equals to or 5%, right? There's only one value which has probability of less than 5%, which is this one of 15, right? I can say it's X1. So you'll have X1, X2, X3, X4. So you will have X1, right? So this is your X, right? So your X over here. Ne? So in terms of finding the values, you'll say that X, again, it is going to be the maximum value of your X's. And what X is there is X1, and X1 is going to be negative 15, right? So since the only answer here, then you can write your answer is what? You can write your answer. You can say that T is going to be negative 15. So perhaps that you had other percentages. Let's just say that maybe there was negative 1% over here. Again, it's negative 1%. And the probability of finding this one was 0.03 and then 0.01, right? Right. So it means that you're gonna have multiple X's now. So two answers where the CDF are less than 5% still, you will have again negative 15 and then negative 1% as well, right? So the maximum of negative 15 and negative 1% is going to be negative 1%, right? Yes. Okay, thank you. So I'm going to move on. Conditional VaR. So for conditional VaR, so we have two things that we can calculate in terms of conditional VaR. So we have expected tail loss, and then we also have expected shortfall. So the one that they, okay, I haven't seen any questions so far. I've checked the past papers where I can find a question that has anything relating to expected tail loss and expected shortfall. Actually, again, they do have question for expected shortfall because it's much easier to find. This one, not so much. So I think that's why they don't test it that much, but then we can do it anyway. So for, again, so here, there is a problem with VaR, right? So we already say that VaR only find that value, right? It only finds that value. It does not say anything about any values below it, right? So here we are trying to find the expectation of the area below VaR, and we call this expected tail loss, right? So expected tail loss is going to be, or you can call it ETL, right? So ETL is going to be the expectation of the value of X, going to be negative X, right? Given that your X is less than VaR. It's less than VaR. I think I should use this ones. So this is the function or the formula they use for X gain for conditional tail loss, right? I mean expected tail loss, right? So so because I haven't seen any question in the exam where they ask this question, there is another definition you can use to calculate a conditional tail VaR, which is okay, which is which you can simplify this thing as. I saw a question in the note where they have simplified this thing. Okay, where they ask you to simplify this thing, right? So that you can find your answer. So my advice, okay, there is another definition actually. They say that X, I mean like the expectation of X It's going to be where X is going to be greater than positive VaR. Right? So these things are the same thing, right? If X is symmetrical, right? Such as normal, right? So they have just switched to the, again, they have just switched to the other side. This area is the same as this area, right? So, and then they use the definition, and then they say that's going to be 1 over minus 1 minus this thing, the expectation of, and then they see that from VaR. So this is the condition, is that X should be greater than VaR, right? So you will have VaR to infinity, right, of X, f of X. So this is the definition you can use if they do ask you a question, because it's so much easier to calculate. I mean, like, to use it. Is by definition. So I try to find how did they arrive to, again, I'm like, I try to find how did they arrive to this answer. I can't seem to find an article that shows a step-by-step why expected tail loss can be expressed like this. But then if they do ask you, then I advise that you use this method, because already you can see that this thing is so much easier for you guys to find the answers. So so there is a question. Again, I am not sure if, let's see, which asks you to simplify this thing on your note. I think I will try to find a screenshot and then send it to the group. I'm sure you all find the thing on your answers. I'm like on your WhatsApp. So it's question I mean, like the, okay, so here's the second question, where they say that X is normally distributed, right? So if they ask you to simplify this thing, like in question 1 over here, question 1, they ask you to simplify this thing over here. They're saying that show that VaR can be written like this. So now they want to know, how can you write the formula for conditional expectation, right? If that question arrives, then this is what you will have to do, right? So you will say that expected tail loss will be equals to 1 infinity VaR. Okay, again, it's going to be difficult to be writing VaR all the time. I'm going to use Q or anything. So Q is the one they use. Many articles I read, it wrote Q. It uses Q. So it's going to be Q times X, f of X dx. We already know that X by, okay, so they told us that X gonna be normal distribution with mu and say sigma squared as our parameters. So you can simplify this thing. You can say that 1 minus integration, not integration, gonna be X 1 over square root of 2 pi sigma e minus 1 over 2 X minus mu over sigma dx. I'm sure that we all know where this one come from, right? Hopefully we all know. And then the next step we take is to say, we can see that this thing is going to be difficult to integrate, right? So we do what we always do in maths. So can we calculate the expected tail loss of the question we just did? Okay, after we have finished here. So again, and then we okay, we try to simplify this thing. So we can say that let z be equals to x minus mu over sigma, right? So if this is the case, then you simply substitute. Okay, you can say that x is going to be equals to mu so dx is going to be sigma dz, right? So your option now is to just simplify these things. So you just simplify, you will have equals to 1 over 1 minus this q sigma. And then in terms of x, you can, where there's x, you're gonna say mu plus sigma z all over 2. You can just say e minus 1 over 2. This thing is gonna be your z squared. So it's supposed to be squared. And then you'll find your dx is gonna be equals to sigma dz. This and this cancel. And then you are left with 1 over 1 minus this. And then you say, you can take out the mu. You have mu integration of q. Actually, it's going to be q minus mu over sigma. Q mu over sigma. And then you will have 1 over 2 e negative 1 over 2 z squared. Dz plus sigma, the integration of going to negative q minus mu over sigma. You will have z z. So we are still together, right? And then I'm going to close the bracket. Close the bracket. Now, because my screen is too small, I think I'm going to do them. Okay, actually, it's fine. There's no need for me to do them one by one. You can already see that this one over here is the function of the standard normal, right? This is by definition the equation of the standard of the standard normal function, right? So to find your answer over here, you can just do this. You will just say equals to 1 over 1 minus this, and then you will have mu. I will just write the mu over there, right? And then I have plus 1 over 1 minus alpha. I can just take this thing here. I can just put it here. So I will focus on this one for now. So I am just going to write this one as it is. Okay. Is that so? You can simplify it further, and then you can do this. You can say mu 1 over alpha is gonna be equals to 1 minus this. It's gonna be q. So this is it, right? So you already know that this thing is gonna be 1 minus alpha, and then your answer is gonna be mu only, mu plus. So your answer is gonna be mu. So you're gonna have mu. So now we are going to focus on the other side, right? By the law of again, is the fundamental theorem of calculus, right? We know that if you have E, let's say you have E, I'm gonna write it over here. You have E to the power negative 1 over 2 Z squared. So the derivative of this in terms of Z is gonna be what? It's gonna be is gonna be negative Z E negative 1 over 2 Z squared, right? I'm right, ne? So by the fundamental theorem of calculus, if you have the integral from infinity q minus mu over sigma squared dz, you will have to do the same this side. Dz. And therefore, this thing is going to be equals to this whole thing over here. It's going to be equals to this. So you will have E minus 1 over 2. So you are going to put the thing over here, the infinity minus the E negative 1 over 2 q minus mu sigma squared, sigma, and then squared, right? So the meeting is, again, the meeting is gonna cut soon because